All right, so today we're finishing up our discussion on segments. We don't have a whole lot more to talk about, just one new term and then some reminders about how to deal with fractions. So let's jump right in. A segment bisector is any ray, segment, or line that intersects a segment at its midpoint. To that list, I'm going to add, because your book does this, most books don't, but yours do, or yours does, any point, ray, segment, or line that intersects a segment at its midpoint. So here we have a diagram, and the segment that we're talking about is segment RS. And the bisector, and bisect, by the way, anytime you see the prefix bi in front of a word, it means two. And sect, if you think about a sect, you usually think about something religious, but actually to sect means to just cut off. If something is a sect, then it is separate, cut off from something else. So we've cut something in two. More specifically, we've cut it exactly at its midpoint. So here, RS is the segment that is being bisected, and line AB is the bisector. So that means that J is the midpoint of RS. And if J is the midpoint of RS, we know that these two segments are congruent to one another. And if these two segments are congruent to each other, we know that they have equal length. Your book is big on saying things like, if point J bisects segment RS, it's easier just to say if point J is the midpoint, but your book likes to say that it's a bisector. And again, just think, oh, well, that means that's got to be the midpoint, and then use whatever you need to do the midpoint problem. All right, so let's talk a little bit about how fractions work if we're talking about a particular problem. So here, if the coordinate of D is 3 1/3, and the coordinate of C is -6 1/4, find the length of CD. Notice there's no midpoint on this, so we're not going to do the midpoint formula. And when we're finding the length of a segment from the coordinates, we're just finding out how far apart they are. So we need to take the difference. So what we're doing here, to find the length of CD, or the distance from C to D, start with the larger coordinate, or the one that's further to the right on the number line. That's 3 1/3, minus -6 1/4. Before we get into the fractional part of this, first thing I would do would be to rewrite it as an addition problem, because it's kind of ugly. So 3 1/3 plus the opposite of -6 1/4 is +6 1/4. Now, from here, I occasionally have students that they want to make this an improper fraction. And you certainly can, and I'll show that in just a second. But it's actually easier not to when you're adding. It's easier to think about this as 3 plus 6, so the whole number here and the whole number here, plus 1/3 plus 1/4. Because all of those are actually being added together. When we say 3 1/3, we're really saying 3 plus 1/3. So when we add those, this is going to be 9. And here's where I have to remind you about adding fractions. You can't add fractions with unlike denominators. Why? Well, here's the simple idea. If I take a whole object and divide it up into 3 equally sized pieces, and then I take a different whole object I'm going to make the whole objects the same size, but this time I divide it into 4 equal pieces. And I say I have a 1/3, so 1 out of the 3 pieces, and 1/4. Are those the same kinds of things? The 1/4 is smaller than the 1/3. I can't combine them. They're not the same kind of thing. So how am I going to deal with that? Well, what I'm going to do is, at least conceptually, I'm going to take this one. That whole was divided into 3 equal pieces. I'll do that again. And then I'm going to take something that was divided into 4 equal pieces. So right in the middle, halfway between those two, halfway between these two. And what I would like to have is things that are broken into the same number of pieces. This is broken into 3 pieces, this is broken into 4 pieces. Multiply that together, 3 times 4, let's break it into 12 pieces. And you're like, oh, that's a lot of pieces. Yeah, it is. So I'm going to break all of these into 4 pieces, each one of them, and break each one of these into 3. And something lovely happens when we do that. Oops, that's in the wrong spot. And you don't have to draw all this when you're doing the problem. I'm just giving you the background on it. And I'm going to break this into fourths. And I'll break this one into fourths. And now all these fourths I'm going to break into thirds. And it's not perfect, but it's not bad. And now I have 12 pieces here and 12 pieces here. Now, the original one was 1 piece out of 3. That was originally right here. So now I don't have just 1/3. I had 1/3, but that's equal to 4 pieces out of 12. And here where I had 1/4, which was, let's see, where was 1/4? There's a half, there's 1/4 was right here. Yeah. Yep, sorry, wrong spot. It was right here. I have all this. Have 1/4. That's equal to 3/12. Now, we don't want to have to go through all of that process to figure out how to get these together. It's easier to go, oh, okay, the least common denominator between these two would be 3 times 4, which is 12. So I'm going to take the 1/3 and multiply it by another name for 1, specifically 4 over 4. And the 1/4, I'm going to multiply it by 3 over 3. So that's 9 plus 4/12 plus 3/12 is 9 and 7/12. And always at the end you look to see if you can reduce that. Notice over here if we add the 4/12 and the 3/12, we get 7/12 also. But we'd rather not have to spend all our time drawing these things out and dividing them up into pieces. It'd be easier to do it this way. All right, let's try this next one. So we have the coordinate of j and the coordinate of k, and we're looking for the length of jk. Again, there's no midpoint, so there's no midpoint formula. When we're trying to find the length of a segment, we're trying to find out how far apart its ends are. So I'm going to subtract. So the length of jk is going to be equal to, I'll take the coordinate on the left, further to the right, the bigger one, which is negative 2 3/4, minus the one that's further to the left, which is negative 5 1/12. I'll rewrite that as an addition problem. This would be plus a positive 5 1/12. All right. We can do the same thing that we did up here, rearranging them. It's just that you got to be careful about it. When you're doing this, this will be a negative 2 plus 5 plus a negative 3/4 plus 12. We have both of those. This is the 3/4 is negative because it's negative 2 3/4. The whole thing is negative. So what do we have here? This is 3 plus the least common denominator between these two is 12 because 4 will go into 12 evenly. So I'm going to take the negative 3/4, I'm going to multiply it by 3 over 3. And the 1/12 I'm going to leave alone. This is 3 plus a negative 9/12 plus 1/12. So that's 3. Negative 9 plus 1 is negative 8. So that's plus negative 8/12. You're like, well, how am I supposed to put those together then, Mr. Davis? Well, you can't. But what you can do is think of 3 as 2 plus 12/12. 12/12 is 1 plus 2 is 3. Now we can take the negative 8/12. And that's 2 and 4/12. And at the end of the problem, I'll go ahead and reduce it. It's 2 1/3. Now, if you prefer to get an improper fraction and do it that way, you can, but especially on this second one, the numbers are fairly big. I think it's simpler not to, but I'll leave that up to you. Good luck on your quiz, and I hope that I will see you on Friday.